Hello everyone, this is Dr. Ali, and in the previous session we started talking about how solving the knapsack problem using recursion methods, and we explained that okay, we need to have the exclude and include path for each node, which we want to evaluate that if we include that the item um, gives us the higher value for the knapsack, or if we exclude it. So based on that, then we go all the way down to consider all the possible paths, and then when we form this tree, then we can evaluate okay, which path is the maximum, which path is the maximum possible, um, basically the path that gives us the maximum possible value. And just for one thing, I want you guys to notice that maximum possible value is different than maximum value, because in this shape, in this tree, maximum value is always this path, because we include everything, right? But maximum possible value is that value that consider the constraint of the knapsack. The knapsack has some limitation of how much weight it has. So that's the only thing that you need to consider. And let's see, I already explained this. Let's see actually in the code. This is the exact same thing, exact same code that I explained in the presentation. So let's run it. And now it says that yes, 120 is the maximum value that we can have. But we want to know that, okay, this is the value that knapsack can carry now with this combination, but which item is included, which item is not included. That's not what it gives us here. It just gives you that, okay, this is the maximum value we can carry, but it doesn't give you any further information. But in order to having the actual sequence, I modified the code a little bit that I explained it to you guys. So first, you remember we had this exclude and include. Whenever that we exclude, I actually in this function we had a space weight value, and I added a list that is always keep track of the sequence. What are the items that we included at this point and the items that we excluded. So whenever we include an item, I add this sequence with this new tuple that says, okay, item n-1 is true, means that the item n-1 is included in this sequence. And whenever this exclude part, we just say false, this n-1, it means that we didn't include that item in the knapsack. And then the rest is the same till we get to this base case, right? In the base case, first I say, what is the maximum possible value? We start from 0. We always keep tracking what is the new maximum possible value. We keep tracking of it, and we compare it with this maximum possible value. And if we say we reach to the end, this part means that if that part, this n equals 0 or a space less equals 0, it means that we already reached to this green circle. So we say, okay, now that you are here at the end of the sequence for each path, compare its values. Actually, sum all the weights and the values. What is the weight for this point and what is the value? So if we go through this path, what is its weight, which is the summation of I3 and I1, because these two are 1, the rest is 0. And also, what is the weight for I1 and I3? So we consider all of this sequence weight and sequence values and see, okay, if this value is more than the most possible value, it means that that's a hit. This is a good selection. So we keep it. We record it till we reach to another sequence that has a higher value than what we have here. And then we keep track it till we finish the program, and then we know that the maximum possible sequence is already captured. So if I run this now, it says, okay, maximum value is 120, and this tells you what are those items that we selected. So item 3, 4, 5, 6 are selected, and the rest is not selected. So what are those three? Item 3, then 0, 1, 2, 3, 4, 5, 6. These are selected, the rest are not selected. So the summation of these 2 plus 1 plus 1 plus 6 is 10. And maximum possible value weight in the knapsack is also 10. So that's correct selection. Yeah, so this is for that's how can we keep track of this sequence. And next session, if you have any question or comment, please leave it down below. So I'll try to respond as quick as possible. And next session, we want to go to see how can we solve the same problem using dynamic programming. That's it. And stay tuned for the next session and have a great day.